Hey there, welcome to this video. This is 12-1. We are starting a new unit on the unit circle. No connection there. But we're going to start talking about a new idea, and that is radians. Up until this point, you have only worked with degrees when we're talking about how do I measure an angle. Well, we've been using degrees, okay? We're going to introduce you to a topic called radians and then kind of show you how we measure stuff in pre-calculus and calculus and trigonometry, okay? All right, so you know that 180 degrees, right, makes a straight line, okay? And it is also possible that angles have a measure greater than 180 degrees, and believe it or not, you can actually have angles that have negative measures. So to illustrate this idea, I want to go ahead and talk about an angle that's called standard position. Now, an angle in standard position, it has a central angle, right? That's a synonym for it. It has a vertex at the origin, okay? So here's that vertex right there, and its initial side is on the positive x-axis. So this is where an angle starts, always, 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 okay? Now, the terminal side, also known as where the angle ends, it can be in any quadrant or on any axis. And here is the terminal side. This is where the angle ends. And we always measure in a counterclockwise direction, okay? So we'll talk about positive and negative here in a second. Okay, so a positive angle is measured in a counterclockwise direction, and a negative is measured in a clockwise direction. So here are two examples. We have a positive 240 degree angle, right? Starts here at my initial side, and then it ends here on this side, and it's rotated in this direction, okay? Now, if I want a negative angle, that's actually the same angle, we'll talk about that later on in the unit, I can go clockwise direction and end in that same spot, and that is negative 120 degrees. We're going to talk about some special angles. They're known as quadrantals. Quadrantals. Can you say quadrantal? Okay, and that is just an angle in standard position with its terminal side on a quadrant. And that makes sense, right? That's why we call them a quadrantal. So here are some of the basic quadrantals. Okay, so I have an angle that ends here at 90 degrees, quadrantal. The next main one is 180 degrees. Then the next one is 270 degrees, and last but not least, 360, if I come full circle. Now, there's also the negative angles included, mostly in this unit and going forward into calculus, you're only going to work with positive angles mostly, but it is important to understand the negatives, and when we get into some inverse trig, you are going to have to understand the idea of negative angle measures, okay? All right, so quadrantals, they end on a quadrant. All right. So let's go ahead and talk about revolutions. Now, a revolution, right, is when I go ahead and spin something around in a circle. So every time it makes one full complete circle, that's called a revolution. So most of the angles that we deal with, at least in this lesson, are going to be in the first revolution. And we'll talk about kind of coterminal angles later on, right? But here are the degree measures for the first revolutions. All right, so what we want to go ahead and do is we want to draw each angle in standard position. So fairly straightforward. In standard position, I'm going to have an initial side here, okay, and I want to measure 135 degrees. Well, I know that this is 90, okay, and I need 45 more, and there is my 135 degree angle, okay? Simple. All right, negative 150, okay? So again, in standard position, I'm going to start here on my positive x-axis, okay? And it's negative, so I have to go clockwise, right? This one's clockwise, positive is counterclockwise. So I'm going to go this way, okay? So again, this is 90 degrees, okay? And I need to go about another 60, okay? So that's here, and there is negative 150 degrees. That's it. Very, very simple. Very, very simple. Okay, here's a practice problem. Please pause the video. I want you to go ahead and try this one. Okay, hopefully you pause the the video, here is your solution set. So 300 degrees, right? You got to go at least 270, right? That's this quadrantal here, and then another 30 degrees more. Negative 45, you're just going back 45 degrees. All right, so we've been talking about degrees. I want to go ahead and introduce radians. So the idea of a degree, it's based upon dividing the circle into 360 equal sectors, where each sector is 1 degree. Now, there's a problem. Degrees are not a real number, meaning I can't insert them into equations and calculate by them and compute with them. So what we do is we are going to introduce this idea of a radian measure. Now, radian measure is a real number, and it's equal to the length of the arc subtended by the angle in the circle with a radius of 1 unit. Okay, and they kind of have a video here, or a visual here. So in a circle of a radius 1 unit, we know that the circumference is equal to 2 pi, right? And you know this, right? The circumference of a circle is 2 pi r. So if my radius is 1, then it's 2 pi all the way around. Okay. So therefore, here's where we get our conversion rate. 360 degrees is equal to 2 pi. So you just need to know, once all the way around the circle, that's 360 degrees. Well, it's also equal to 2 pi. Okay, and pretty easy, right? Circumference formula is 2 pi r, so 2 pi. All right, so what we're going to do is we're going to reduce this. And if I have 2 pi radians over 360, I can go ahead and reduce by 2, and we get pi radians over 180 degrees, and this is our conversion rate. So every 180 degrees, that's pi. Every pi, that's 180. So here is the main ratio that you need to remember or memorize, which honestly is pretty simple and straightforward, okay? So what if I want to go from degrees to radians? Well, I want radians on top, right? I want to be in radians, so radians has to go on top. I want to get rid of my degrees, right? That's why degrees is in the bottom. So what if I want to go from radians to degrees? Well, if I have radians, I want to get rid of them. It goes in the bottom. We're going to divide by them. And if I want degrees, I'm going to multiply by it, right? So I put degrees on the top. Okay, so there's your conversion rate. Now let's go ahead and look at some examples and give this a go. Okay. First, I want to go from 135 degrees, and I want it in radians. So I'm going to multiply by, okay, I want radians. So pi radians in top. Okay, so pi rad over 180. Okay, now I'm going to go ahead, and what I'm going to do is I'm going to reduce this. Okay, and I'm going to reduce by 45. Okay, so that leaves me with 3 pi over 4. Okay, and I'll just make a note here. Reduced by 45. Okay, and that's a kind of a trick here. You're going to reduce always, well, almost all the time. Reduce by 30 degrees, you'll reduce by 45 degrees, or you'll reduce by 60 degrees. So if you're like, man, this is huge, I don't know like what value to reduce by, it's one of those three. Okay, let's go ahead and look at another example. All right, so I want to go from 570 degrees to radians. Okay, so I'll multiply by pi over 180. Okay, and it's implied that it's radians. So the degrees cancel. Okay, and again, I need to go ahead and reduce this. Okay, so 57, I can cancel the zeros, right? 57 over 18. Well, I'm going to go ahead and reduce by 3, right? So I'm reducing by 30. Okay, and if I do this, we get 19 pi over 6. And there it is, right? That's radian measure. Very simple. Okay, what about if I go from radians to degrees? Okay, so I want to get rid of my radians, so I'm going to divide by pi radians. Notice that pi is not in radians by itself. Just because you're using pi doesn't mean it's radians, right? You can still work with pi in degrees, but just a disclaimer. Okay, so I'm going to multiply by 180 over pi. Okay, so the pi's cancel. All right, and then 6 can reduce into 180 30 times. So 30 times 5 is positive 150. So 150 degrees. Simple. Very, very straightforward, right? Just the reducing is the trickiest part. Okay, 30 degrees. I want to go to radians. So I'm going to multiply by pi over 180. Okay, I can reduce obviously by 30. So we get negative pi over 6. There you have it. All right. I want to multiply by 180 over pi. Going from radians to degrees. Okay, so the pi's cancel. I'm going to divide by 4 with 180. That gives me 45. And negative 9 times 45 is negative 405. Okay, and this is degrees. All right, so there you have it. Here is a practice problem. Please go ahead. I want you to pause the video. Try these. Remember, you got to reduce by 30, 45, or 60 when you're going into radians, okay? All right, so hopefully you have paused the video. Here is the solutions. All right, did you get those values? All right. Okay, so now that we've talked about radians and degrees, we're gonna circle back to graphing angles. So now if I have a revolution, right, knowing that 180 degrees is pi. So if I go halfway around, right, that's pi. Okay, if I go all the way around 360 degrees, that's 2 pi. And I can apply this idea. What if I only go, halfway to pi? Well, that's pi over 2, right? So pi over 2 is 90 degrees, okay? And then I can also, right, have pi over 2, 2 pi over 2, and then add another pi over 2. That gives me 3 pi over 2. So that's how we get the first revolution in the positive, okay? And then what about negative? Well, you're just going the other direction, and you slap a negative on it, okay? Fairly straightforward. All right, so here we want to draw each angle in standard position. I want pi over 3, okay? So I have my initial side, and I know that this is pi. So I want 1/3 of that. So 1/3 of this arc. Well, that is roughly here, okay? Pi thirds. Simple. All right, negative 5 pi over 4, okay? So here is my, oh, it's terrible initial side. Here is my initial side, okay? And I'm going negative, so I'm going to go around here. So that's pi, but notice my denominator is out of 4. So isn't this 4 pi over 4, right? That's 1 pi, 4 pi over 4. And I want another 1/4, okay? So that's here. Right? So there is negative 5 pi over 4. All right? And that's graphing an angle. So kind of a trick, if you're working with a denominator, think about splitting pi by that denominator, right? So if I was over here, this would be 3 pi over 3, right? I want 1 pi over 3, so I want one of them, okay? That can help. All right, here's a practice problem. Please go ahead, try this, and I will show you the answer. All right, so hopefully you went ahead and tried these. Here is the solution, and this is what you get. Again, I'm working with negative 5 pi over 6. So this is pi, so that's going to be 6 pi, negative 6 pi over 6. So I want one less, right, which is there. Okay, and then here, 7 pi over 4. Okay, well, this is going to be 4 pi over 4. Right, and then 2 pi, this would be 8 pi over 4. Well, I want one less. So that's how I get that. Okay, that is it for this video. Now you know about radians, degrees, and radians. Really quick, what's the conversion rate between degrees and radians? 180 for every pi. All right, hey, I'll catch you in the next video. Peace.